No, it's 19. Hashtag let's have some fun. Don't worry, it's going to be not that bad. So first, real quick, these you already know. One function is an odd function, which is an even function. So you see this graph here, sine theta. Sine theta is an odd function. This is an odd function. Cosine theta is an even function. It's symmetric on the y-axis, even. And then tan is another odd function, and you say that odd functions are symmetric about the origin. That's what you say. So it says which function is an odd and which is an even. Well, if sine's an odd, that means its reciprocal is also odd. So what does it mean to be an odd function? Sine of negative theta is equal to negative sine theta. That comes from the definition of odd. F of negative x equals negative f of x. Do you guys remember that? So hopefully that's not new to you guys. That's from like algebra 2 and stuff like that. What else is odd? Well, sine's odd, then its reciprocal is also odd. So cosecant of negative theta is equal to negative cosecant of theta. That makes sense? Can you guys hear me, or is the fan too loud? Okay. So this is an odd function. Let's see, what else is odd? Well, tan's odd. Tan of negative theta equals negative tan theta. So is its reciprocal. So cotangent of negative theta, cotangent of negative theta is equal to negative cotangent theta. And cosine's even. So an even function follows this property, f of negative x equals f of x. So that means cosine of negative theta equals cosine theta. And if cosine's even, that means its reciprocal is also even. So secant of negative theta is equal to secant of theta. Nothing crazy, right? Okay. All right, so there it is. Let's see, what else? So this is just reiterating what we just did over there. It just has the argument x instead of theta. But it's the same thing. No big deal. Same. Do we need to talk about odd and even? Are we pretty good about that? Okay, we already know that, by the way, right? Okay. Jump to the next page, and we should already know about this, but just in case, John, what does this mean? The CoFunction properties, functions. All right, so really what we're trying to tell you guys here is that cosine of 90 degrees minus theta is the same thing as sine theta, and that sine of 90 degrees minus theta is the same thing as cosine theta. But sometimes it's kind of hard to see. Like you're like, I don't understand, Chav. Why do you have the 90? Cosine and sine just differ by 90 degrees. But you can, sorry, I'm trying to, the fan's kind of bothering me just a little bit, but it's fine, it's fine. If you draw a right triangle, guys, you can see this in action. Chav, what are you talking about? Let's see, alpha and beta. And all three of these angles summed together have to add up to how many degrees? 180. So check it out. 90 degrees plus beta plus alpha has to equal 180 degrees. All I'm doing is these three angles. And if I were to get like beta by itself, so let's say I were to move this to the right and that to the right. So we'd have beta equals 180 degrees minus 90 degrees minus alpha. And then 180 minus 90, that's just 90 degrees minus alpha. Chav, how does this prove that? Well, let me show you guys. SOHCAHTOA. I'm just going to make up some. Do you guys prefer numbers or letters? Letters? I heard letters. Letters? Numbers? Numbers? Okay, numbers. 3, 4, 5. It is a 3, 4, 5 triangle. If I were to tell you cosine of beta, you would tell me cosine is adjacent over hypotenuse. You would tell me 4 over 5. Yay or nay? If I were to tell me what sine of alpha is, you were to tell me, oh, sine is opposite over hypotenuse. You would tell me 4 over 5 again. Yay or nay? Yeah, and I know you guys are saying, like, Chav, how is that going to prove this that you just said? Well, if I do this, if I go, oh, look, this is beta, and I say beta equals 90 minus alpha, which is, look, that's what we're trying to show here. So look at this. You see how that says beta on it? I'm going to sub and look at this. Cosine 90 degrees minus alpha equals 4/5. Oh, look at that. Sine of alpha equals also 4/5. Are these two equivalent? Does cosine 90 minus alpha and sine of alpha equal the same thing? So look, we can write this statement. Cosine 90 minus alpha is the same as sine of alpha. I'm just trying to prove you don't have to write equals, but if you did, you could say both of those equals 4/5. I'm just trying to prove this statement here. And you can go back and forth between alpha and the beta. See, I'm trying this one right here. See? Cosine 90 minus alpha equals sine alpha. Replace the alpha with a theta. Cosine 90 minus theta equals sine theta. Cool, right? Okay, so now we got this on lock. I think we're good. I think we're about to do something special that I hope you guys like. All of these statements are true, especially the cosine and sine. This is the one that we're going to be using mostly. But all these statements are true, but these are the top two ones are the ones that you're going to use. This is if you're in radians, and this is if you're in degrees. Now, I think you guys, what do you guys like better, degrees or radians? Degrees? Okay. Did you guys say degrees or said radians? I can't hear you with that fan. Radians? Okay. All right. We can do radians. Let's see. Yeah, we can do radians if you guys prefer that. All right. You guys ready? It says, all right, I think we're ready to derive the composite argument property for cosine A plus B. We're going to do a hack. What property do we know? Come on, Baya, focus, miss. We know cosine A minus B. Hopefully you've done enough problems that you know what's up with this one. What's cosine A minus B? The same thing as cosine A, cosine B, plus or minus? Plus. Plus sine A, sine B. Do you guys remember that from last week? Okay, we're going to do a hack. This is the only thing we know. We don't want cosine A minus B. We want cosine A plus B, but we don't know what cosine A plus B is. So here's my hack. I'm going to write cosine A plus B because that's what I want. I do not know it yet, but that's what I want. And I'm going to do a hack. I'm going to write equals cosine parenthesis A minus a negative B. Chav, what are you doing and why? Hey, no, Yanni, that's a demerit. I know what cosine of A minus B is, or cosine of some angle minus another angle. So look, bless you. I have cosine of an angle minus another angle. Do you guys see that? And notice if I distribute this negative, what's negative times a negative? Positive. So do you guys see the hack that I'm trying to use? So Chop, what's the hack that you're trying to use? I'm gonna use the only formula I know, that guy. But I'm using it. Look, I changed the angle from a positive B to a negative B. And now this is still the same as cosine A plus B. Do you guys see that? So now I'm going to say, well, all I'm going to do is just this, right? I'm going to go cosine A, cosine, but instead of writing cosine B, I'm going to write cosine of negative B plus, that plus is this plus. See, that plus is that plus. Sine of A, and you don't have to put a parenthesis on the A, but I just did. Sine of negative B. Are we still okay? Now check it out. Look how awesome this is. Cosine A is still cosine A, so you leave it alone. But cosine B, I guess I already put a parenthesis. Cosine is an even function. Here it is. Where are you? Cosine's an even function. So I guess put a side note here. I guess I'll put it here. Side notes. Cosine of negative B equals cosine B. And sine's an odd function. So this is an odd. And this guy right here is an even. So sine of negative B equals negative sine B. Couldn't fit it in there. Let me write it better. Because sine is an odd function, guys. So I'm going to write it up here. Negative sine of negative B equals negative sine B. Because sine's odd. This is my side notes. Does that make sense? So cosine A, cosine of B plus sine A, parenthesis, sine of negative B is the same thing as negative sine b because it's an odd function. Are we still okay? Check it out. This doesn't change, so this is still just going to be cosine A cosine B. What's positive times a negative? So change the sign. Hey, no yawniness. That's a sine A, sine B. With a change of sign, change that minus to a plus, and there it is. So hence, cosine A plus B is just cosine A cosine B minus sine A sine B. So now we know 2. Are we okay? Are you not entertained? How do you guys feel? Granados, how do you feel? Do you guys speak Spanish? ¿Cómo te sientes? Or did I say, how do you sit? That's how you say, how do you sit too, right? ¿Cómo te sientes? How do you sit? Okay, Henderson's like, I don't know what you're talking about. All right. LOL. Let's just continue. Here it is. That's another formula that we know. Add it to your bag of formulas. Let's shoot for this one. We could actually find this one with the way we did cosine A minus B. Do you guys remember when we did the unit circle? You okay, Gauda? You okay? Okay. Do you guys remember when we did the unit circle, the first quadrant, and we solved cosine A minus B using the distance formula? We could actually do sine A minus B with something similar, but we're not. This is what we want. So I'm going to write sine. I'm going to do a hack. Here's another hack. Sine A minus B. And I'm going to group these together, guys, like this. That's going to be like an angle. Like theta. Don't worry, just follow along. And I'm going to write this like this. Cosine. What do you guys want? Degrees or radians? Radians. Cosine pi over 2 minus A minus B close. Chop. I have no idea what you just did. Make a side note. All I did was this. I'll put both of the formulas in here. Sine theta equals cosine pi over 2 minus theta, or cosine theta equals sine pi over 2 minus theta. They both mean the same thing, guys. Remember what we just talked about? The phase shift. We just did this a little while ago. You can replace a 90 with pi over 2. You can replace a 90 with pi over 2 in there. See? Yeah, pi over 2 is 90 degrees. All three angles add up to pi. See, 180 degrees here. You can put a pi there. Turn that 90 into pi over 2. And then when you move this, you can have a pi here minus pi over 2. And then this right here that I'm writing, that's just pi over 2 right there. See? You know what I mean? Cool, right? All right, that's all you need. So this is what I did. See? This is like sine of theta. I'm just doing this top one right here. So I just moved that together, pi over 2 minus my angle there. Do you see how that's still the same? Check it out. I'm going to distribute that negative to do another hack. I'm going to write cosine pi over 2 minus A, and then minus a negative plus B, close. Are we still okay? What do you think, Lizette de Rodriguez? Right. Now look what I'm going to do, guys. I'm going to put a parenthesis right there. I can put parentheses wherever I want. So now this is like my new theta. Like new theta. Do you guys see that? And we just figured out what cosine of theta plus B is. Look, it's right here. Cosine of some angle plus some angle is this formula. Do you guys see that? So now I'm just, or am I just talking gibberish, or do we like genuinely see that? Okay. So now look at this. I can write this in blue is my new angle. So cosine of pi over 2 minus A, and then that says cosine B. That's still cosine B. So cosine B, and then that minus is this minus. That minus is this minus. See, because there's a plus there. Sine of what? pi over 2 minus a cosine of b. So catch up to here. What's up, Hernandez? Why is it what? That's just a formula. Oh, you're right. You're right. See, I messed up. That's not cosine b. That is sine b. That has to be this one, guys. Yeah, I messed up. I didn't do it on purpose. Thank you, miss. Make mistakes all the time. Are there any other mistakes? Do you see any other mistakes, Gouda? No? So we're good? Miss, there's another mistake. No, there isn't. Sorry, miss. I won't do that to you again. All right. I'm just testing, seeing if you're awake. Are you guys okay? Well, these guys are having a good time. All right, next. Look at this right here, guys. Cosine pi over 2 minus a. That is something. Go to the previous page. If you got to check the radians, you can turn all those x's into a's. I guess you just need the first line here. What is cosine pi over 2 minus a equal to? Yeah, what is it? Say it loud and proud. Sine of a. So I can rewrite this one right here, guys. That's just sine a. So now look what I have. So I'm going to have sine a cosine b minus, and then what is sine pi over 2 minus a? Yeah, look, it's this one right here. Sine pi over 2 minus a is just cosine a. So I come back, cosine a, sine b. OMG. So, sine of a minus b is nothing more than sine a cosine b minus cosine a sine b. There it is. Isn't that cool? All right, take a guess. We don't have to do this over and over again. What do you think if sine a minus b was that? And remember, look, I guess I can write the other one here. Cosine a minus b. Let's use context clues. This was cosine a cosine b plus sine a sine b. So there it is. That's this one. Notice the difference. There's a plus here. There's a minus. There's a minus here. There's a plus. Okay. Sine a minus b. Sine a cosine b minus cosine a sine b. What do you think sine a plus b is? Sine a plus or minus? This one's plus. Cosine a sine b. Look at all those patterns. We got rid of two of them. Now maybe you're saying, Chav, when am I going to use this and how do I use it? Guys, there have been entrance exams, and I've also seen it on math quizzes. I have seen, and I stole this from UH. I have seen when we used to go to UH, this math contest was with no calculator, and I've seen like our kids were like, "Man, Chubb, there was this question. I needed a calculator." No, you don't. You just got to recognize it. So look, what if this is an entrance exam to one of your universities? What if MIT asks you this question out of 3 questions? So you see this. Look, there's a 5x, 3x, 5x, 3x. OMG. That looks like an AB scenario. And it equals a half. That's a perfect coordinate on the unit circle. 1/2, or square root of 2 over 2, or square root of 3 over 2. And this looks like to me, so I'm going to write sine A cosine B minus cosine A sine B. Look at that, guys. Sine A cosine B minus cosine A sine B. This is toggling, so I know it's a sine. And because there's a minus for the sign keeps the sign. So this has to be a sine A minus B. Job, I have no idea what you're talking about. I'm just talking about this. See? Sine A minus B, sine A cosine B minus cosine A sine B. The signs toggle between sine and cosine, and the cosines do not toggle. Cosine, cosine, sine, sine. The cosine, if it has a plus, it's a minus. If there's a minus, it's a plus. Do you guys see that? The signs keep the sign. So if there's a minus, it's a minus. And it toggles between sine and cosine. Sine, cosine, cosine, sine. Cool or not cool? So here's how you would do this. without a calculator. So put without calculator. So without a calculator, you would recognize that the left-hand side is nothing more than sine of 5x minus 3x, and then that just equals that half. That half, just bring it down. See? And now, what is 5x minus 3x? So I'm going to write sine 2x equals 1/2. Without a calculator. I'm going to get rid of that sign. So I want to because I'm trying to solve for x. So I'm going to write 2x equals arc sine of 1/2 plus 2 pi n. Are we still okay, guys? All right. Here's my unit circle. Sine is 1/2. Bam, right here. And bam, right there. What's this first coordinate in radians? Pi over 6. Pi over 6 plus 2 pi n. Semicolon. What's my next coordinate in radians? 5 pi over 6. I'll wait. Here, I got it. Sorry, I'm not picking on you, miss. It's just that you keep, so if you get tired, feel free to get up. I'll put some standing desks on the outsides. So I'll pick them up. There used to be standing desks on the hallway. What happened to them? Who took them? All right, how do I get x1 and x2 by itself? Not everyone at the same time. Divide by what? So pi over 12 plus pi n, semicolon, n is just a number, n is just an integer, depending on how many cycles we do. Divide by 2, divide by 2, divide by 2. x2 equals 5 pi over 12 plus pi n. All right, guys, here's my answers. Semicolon. X equals, I'm only looking between 0 and 2 pi. So my first answer is pi over 12. My next answer is 5 pi over 12. My next answer, take the pi over 12 and add pi to it. Just put 12 over 12. See, that's my common denominator there. 12 plus 1? 12 plus 1, 13, right? 13 pi over 12. It's still between 0 and 2 pi. I put 12 over 12, common denominator. 12 plus 1 pi. Right? Or no? You guys got to ask me, guys. I can't read minds. Well, sometimes I can. Is everyone okay with the 13 pi over 12? You guys know how I got it? Okay. There's one more, guys. Turn this into 12 over 12. There it is. That's still pi. That's still 12 pi. That's still pi. 12 divided by 12 cancels out. I just did a common denominator. What's 12 plus 5? 12, 13, 14, 15, 16, 17. 17 pi over 12, and that's still below 2 pi. And that's it. You can't add 2 pi anymore, or you can't add pi anymore to the 13 pi over 12, because then you'll be above 2 pi. 25 pi over 12, right? And 25 pi over 12 is bigger than 2 pi. There it is, guys. You can always check it. You can always type it to Y1 and see if, put that in Y2. Like, let me use Desmos, because Desmos is so pretty. Desmos will also give you the exact answer. And then later on, we'll see how we can get our calculators to give us those. But look, do I have? Yeah, I do. Desmos is on. All right, just go to Desmos. Desmos.com. I love Desmos. Open graphing calculator. All right, give me the original. Cosine, was it 5x? Cosine 3x. Was it plus or minus? Plus. Was it? See, I don't know, guys. See, you got to tell me. Sine 5x. Cosine 3x. Plus or minus? Minus. Cosine 5x. Sine 3x. Look, guys. So there it is. And now I'm just going to type 1/2. Oh, well, I guess I got to type y equals. Y equals 1/2. And chop, which ones do I get? Put the little wrench. Search between 0 and 2 pi. 0, 2 pi. And then just click. Look, click. Power 12. There it is. Thank you, Desmos. 5 power 12. Thank you, Desmos. 13 power 12. Thank you. And 17 power 12. And so, isn't that so awesome? You could do this in the calculator, and the calculator would do that too, but your calculator will just give it to you in decimals, which I'm assuming, let's see if I click, just puts it there. 0.2617. This is what the calculator answer would give you, the decimal there. All right. How do you guys feel? Do you guys feel good? You guys ready to do the tan? I don't see any issues. I think we're good. Okay, let's do the tan, guys. All right, here we go. Let's derive one more. Let's just derive this one last one. We haven't skipped any, dude. Have we? No, we haven't skipped any. Okay, here we go. Let's derive one more. Tan A minus B. Tan A minus B. Well, we know tan is the same thing as sine over. Do you know what tan is?
Wait, repeat.
What is tan? Something over something.
Wait, what?
Tangent?
Sine over cosine.
Sine over cosine. So we know that. And we already know what sine A minus B is. Sine A minus B is sine A cosine B plus or minus. Minus cosine A sine B. Sine A cosine B minus cosine A sine B. Just toggle it. And then cosine does not toggle. Cosine A, cosine B, and if they have a minus here, this is going to be a plus sine A, sine B. Are we still okay? All right, I'm going to cheat a little bit because there's many ways to go. You see how I want the 1 in the bottom left-hand corner? So I want a 1 here in this corner right there. So how do I get this to be a 1? Is the only things I can do is divide and multiply. I'm going to divide this and every term here by that exact term, cosine A, cosine B. So I'm going to take a different color. Let's see if you can fit it. You don't have to be perfect. Divide by cosine A, cosine B. Whatever you do to 1, you do to all of them. Let's see. It doesn't have to be perfect, guys. I should have told you guys that we were doing that. I didn't know until I had to take a sneak peek. There's so many ways to go, you know. If you Google these formulas, you might see them written a little different. There's so many ways to go, but this is how this author wrote them with the 1 in the corner there. All right, when you do that, I guess I'll go ahead and show you here. So here it is, the upper left-hand corner. I'm just writing sine A, cosine B, and I'm just dividing by whatever I have here in black. Cosine A, cosine B, minus cosine A, sine B divided by whatever I have here in black, cosine A, cosine B, over cosine A, cosine B divided by cosine A, cosine B, plus sine A, sine B divided by cosine A, cosine B. So catch up. I know, guys, everyone's tired. Not only is this room hot, but it's also the last period. But bear with me. Next year, you'll have calculus in the morning, so you'll have more energy. Are we still okay? All right, so here's my 1. I guess take a different color or just cancel stuff that you can see that you cancel. Look at this in the top left-hand corner. I see a cosine B and a cosine B. Bam, out. Do you guys see that? Top right-hand corner, I see a cosine A and a cosine A. Bam, out. Bottom left-hand corner, all that is the same. So all of that is just going to be a 1. A Juan. And no yawning. No drawing, Herrera. Demerit. And I can't cancel anything in the bottom right-hand corner. So what do I have? Well, sine A over cosine A, that's just tan. Tan A. Minus sine B over cosine B, that's just tan B. This is 1. And oh, look at that. Sine A over cosine A. Plus, that plus is this plus. That's tan A. Sine B over cosine B, that's tan B. So there it is, guys. You got another formula. So what's another formula? Tan of A minus B, that's a minus, just the squiggly came out a little funny, equals tan A minus tan B over 1 plus tan A tan B. All right, take a guess. And I know, I'll wait for you guys to catch up. Why do you sit over here and sit over there? You should feel better. You see that? No, you're this. There's no violence in here. I'm sorry. You can sit wherever you want. Who's absent though? Oh, okay. This is good. All right, guys, take a guess. All right, Granado. That's a demerit, miss. I'm kidding. What is tan A plus B? Take a guess. Tan A plus or minus? Plus tan B over 1 minus tan A tan B. I hope you're happy, guys. I know I could have. Okay. I don't want to be that teacher, but I don't know. You guys tell me. Maybe you guys, maybe that's what you want. Turn the page. We just derived all those formulas. Don't you feel happy that we just derived all those formulas and we know where they're coming from and we're not just saying, here's some formulas, just use them? I mean, I don't know. Maybe you want me to just tell you, here it is, just use them. Guys, they all come from somewhere. We derived them all. This is the first one we derived. We derived this one here with the unit circle. I don't know if you remember. You guys remember when we did that? I think it was that one. That's the one we derived with the unit circle with the distance formula. And then we derived this one a little while ago with a hack. And then we did the sine A minus B with a hack. And then we just guessed what sine A plus B could look like. And then we derived tan A minus B with a little help, knowing that there was a 1 in the bottom left-hand corner. And then we guessed how tan A plus B looked like. Isn't that cool, guys? All right, how do you use them? Oh, by the way, you'll get to use a note card for this Friday, but you won't be able to use a note card for your exam, for your semester exam, just for the quiz. So for your quiz on Friday, you can use a note card, and you can put these in your note card just for the quiz. For the exam, on the AP exam, there is no formula chart, guys. So hopefully by the time we take the semester exam, you've had enough practice with these that you won't need them. You know what I mean? What's up?
On the semester exam or on the quiz, are we going to be tested on how we derive the equation?
No, just using them. All right. So what's up? Just a quiz on Friday. If you need a formula on the exam, like you need a formula, I would give it to you. But remember, on the AP exam, they will not give you any formulas. So I'm tempted to not give you any. You know what I mean? So you'll be fine. All right. Does everyone have this activity here with them? Don't worry. We're going to do 2 of them together. You guys choose number 1, number 2, or number 3. It does not matter which one to me. They all look the same to me. 1, 2, or 3. You guys choose as a class. Number 3? We're going to do 2 of them. So either 1, 2, 3, and then I'm going to tell you to choose one from 4, 5, and 6. Are you guys sure you want number 3? I mean, if you guys want number 3, we'll do number 3. All right, that's what you guys want. Number 3. So everyone go to number 3. I would have chosen number 1 because number 1 is the one that doesn't have a perfect coordinate. But no. Wait. All right, number 1. You guys are so funny. All right, here we go. I look at number 1 and it says cosine, sine, sine. It wants me to do it algebraically. So I obviously am going to have to solve with doing some stuff. We just learned the composite argument properties. Sometimes they're called angle addition formulas. I'll give you all the different names later on. But all right, so I look at this and you're like, that looks familiar. That looks like what? Yeah, it looks like cosine A plus B. I'll write the formula up here. Cosine A plus B is cosine A cosine B minus sine A sine B. That's what it looks like, doesn't it? So I come back and I write, okay, this x is like my A, that 0.6 is like your B, that x is like A, that 0.6 is like B, and I'm going to go cosine, open parenthesis, x plus 0.6, close, equals 0.9. Are we still okay? All right, next, well, the whole thing here is that you're trying to solve for x. So I'm going to get rid of that cosine, and I can get rid of that cosine by doing what? Inverse cosine. X plus 0.6 equals plus minus arc cosine of 0.9 plus 2 pi n. The plus minus is only for inverse cosine. Inverse sine does not have it, and inverse tan does not have it. That's a common mistake. Whenever you guys get to another one, I see you guys do plus minus arc sine. No, do not do plus minus for arc sine. That's only for arc cosine. Are we still okay, guys? Okay, next. I'm going to move that 0.6 to the right. Just move it right in front of that. X equals negative 0.6 plus minus arc cosine of 0.9 plus 2 pi n. Are we still okay? I'm going to write x1. I know, we're tired, guys. And I'm going to type that into my calculator with the plus, and then I'm going to change it to a minus. So take your calculator. Here's where your calculators are going to finally come in. Make sure you're in radian mode. And it says negative 0.6 plus arc cosine of 0.9. So that's what I'm going to type in. Negative 0.6. I guess I could have just put 0.6. Plus arc cosine of 0.9 or 0.9. Enter. There it is. Negative 0.14897. Negative 0. I already forgot it. 14897. 14897. 14897 plus 2 pi n x2. Instead of a minus, I'm going to do what? Instead of a plus, I'm going to do what? Minus. So just bring it up, just scroll up, and then just hover over the plus and put a minus. And there it is, negative 1.05102. Negative 1.05. 05126. These are what you call general equations. We've talked about that before, right? Those general equations will give me all the answers, all of them. I am only looking between what and what? 0 and 2 pi. So here it is. I'm going to write x equals, so this is not an answer because it's not between 0 and 2 pi. But if I add 2 pi to that, I'm going to get an answer. So I take my calculator and I scroll up to the negative 0.14 and I push enter and I go plus 2 pi. And there it is. This is an answer. 6.13421. 6.13421, comma. I do the same thing. I grab this negative 0.105 and I add 2 pi. So I'm just going to grab that one right there. Enter. And I'm going to go plus 2 pi. It's going to be like 5 point something. 5.2321 or 22 if you round. 5.2321 or 22 if you round. 21 truncated. And there it is. If you have access to Desmos, you can check it real fast. You can also type it into your calculator. It's not a big deal. But let's see if I can remember. Sometimes I can remember, sometimes I can't. Cosine x, cosine 0.6. So let me go to Desmos. And clear. And then hook me up with the original. Cosine x, cosine 0.6, plus or minus. Minus sine x, sine 0.6. So there it is. I got to put y equals, I guess. Hey, where is it? Oh, I guess it wants the parentheses on the x. Okay, there it is. All right, here we go. What did I want it to equal? 0.9, right? 0.9. All right, this one's not going to give me a decimal. I mean, it's not going to give me a pi in terms of pi. Check it out. Boop. Did we get 5.2321? Chop, why did it give it to you in terms of pi? Because 0.9 is not a perfect coordinate, like half, like square root of 3 over 2, like square root of 2 over 2. If it was one of those, of course it would be a perfect. And look at the other one. Where's the other one? Way over here. Boop. 6.13421. Cool, right? All right, one more. From 2, 3, I guess, I mean, if you wanted to, we can do one more of these, but I'd probably do one more of the degree modes, but you guys have free will. If you guys want to do 2 or 3, let me know. But look at 4, 5, and 6. I would do one of those instead. Which one looks most interesting to you? Yeah, I would have chosen 5 also. All right, number 5. What mode am I in? Degree. You don't, yeah, go ahead and put your calculator in degree mode just in case we use it in a little bit. But you don't have to. Do you recognize this, guys? I would like for you to recognize that this is square root of 2 over 2. Because that's just 1/2 times square root of 2. See? But you don't have to. You have a calculator. You would have gotten the same answer, even on degree mode. And then look. Sine, cosine, cosine, sine. What does that look like to you? A what? A cosine or a sine? A sine. I'm going to write the formula right here real quick. Sine A plus B. Oh, that's a minus. Sine A minus B is sine A cosine B minus cosine A sine B. Do this 3 times and you'll already have it memorized. So here it is. I'm going to rewrite it. Sine. I guess I'll write it one more time. 3 theta cosine theta minus cosine 3 theta sine theta. And that 3 theta is like an A. That theta is like a B. A, B. So I'm going to go sine, open parenthesis, 3 theta minus theta. Close it. And that equals what I have here on the right-hand side, square root of 2 over 2. Are we still okay? Sometimes I can combine like terms. Sometimes I can't. I have a 3 theta minus theta. So that's going to give me 2 theta. Are we still okay, guys? Okay. Next, I'm going to do inverse sine to get the 2 theta by itself. So 2 theta equals arc sine. Arc sine does not have plus minus, so do not do that. Plus, and I'm in degree mode, 360n. I'm in degree mode. If you want, you can type arc sine of square root of 2 over 2 in your calculator, but I would like for you guys to be able to figure that out without it. 2 theta 1 equals sine is square root of 2 over 2 the first time right, bam, right there. What angle is that in degrees? 45. That's what you said, right? Put plus 360n. Oh, my gift. And then 2 theta 2. There's another one. Bam, right there. Negative square root of 2 over 2, comma square root of 2 over 2. What angle is this one in blue? 135. Are we okay? All right, guys. Let's just divide by 2 everything. I'm doing 2 theta 1 here, so I'm going to solve that one down here. Divide by 2, divide by 2, divide by 2. So theta 1 equals 22.5 degrees plus 180 degree n. And theta 2 equals, divide by 2, divide by 2, divide by 2. 60, 60, 120, 70, 60, 67.5. I make mistakes all the time, guys. Check them. 135 divided by 2, 67, 67, 77, 13, and I got a 5, yeah. 77, 14. Oh man, maybe I messed up. Let's just do it. 135 divided by 2. Yeah, we got it. All right, here are my answers. theta equals, my first answer is 22.5. Put a degree symbol or else it's not a degree. Second answer. Third answer, they want all of them between 0 and 360. Add 180 to the 22.5. 180, 200, 202. 202.5 degrees. And then the last answer, 180 plus 67.5. 180 plus 180. 247.5. There it is. I would check it. Chav, how do you check it? The same way we've done all of these. Either Desmos or a calculator. Since I have Desmos already here, I'll just type it. Hook me up with the original, and I'll change it right now to degree mode. What was it? Cosine, or was it sine? Sine 2 theta or 2x. Sine, 3x. 3x, and then what was the other one? Cosine x plus or minus? Minus cosine 3x sine x. All right, so there it is, and I'm doing a bad habit of not putting y in front of that, but that's fine. And then 0.5 square root of 2. Okay, I didn't put a q. I guess I have to do tons. Let me rewrite it again. Y equals 5 times sqrt 2. Oh, it was half. It was half. How come you guys didn't tell me? There it is. So check it out. Oh, by the way, I'm still in radian mode. Click the little wrench here. Put degrees. So then I'm going to have to change the 2 theta to 360. And there it is now. Okay. First one. Click. 22.5. That's a degree. There it is. 67.5. There it is. And then the period. If you go plus 180 on this. 202.5 and 247.5. Cool or not cool? Not that bad, right, guys? All right, guys. I know it's you guys got 30 minutes. I think that's enough time to maybe finish it, but I get it that it's also really hot. But let's see how much you can get done, and that's it. We'll call it a day.